All right, so I looked at the document that Biohazard 4X put up, and it just shows a demonstration of Leon's leg bending at to the right, then to the left, and then going forwards. And the significance of that is just the value that he changed. It's not a value that I thought would do that. So that value I thought exclusively just changed the data type. So when I worked on dead rising, now mind you, I only worked on models. I only ever worked on models. I don't really go outside of that. Like animation is not a thing that I'm used to working on. But usually when you're dealing with models, you have models that are important and models that are not so important. So you might have a model that's like in a background, like this lamp, and like who gives a shit about the lamp? So you'll basically down res that that geometry will be like shit, basically. Who cares, right? So usually what you do is you use a smaller resolution, a smaller precision, or whatever, and you use that to store your data. Because like who cares if it looks like shit, right? And then you put your high precision and all your good quality stuff in your cinematic models or your player models and that kind of stuff. So I thought that's what that was. Like this is just saying, oh hey, this is a type whatever, so there's more stuff to do stuff with. Here, have more stuff. But it's obviously not doing that. It's actually changing the pole, I believe, uh, position of the leg. So just do a little crash course on inverse kinematics. I have a skeleton of Leon, so we'll just go there real quick. So if you're an animator and you want to like make a walking animation, by the way, I recommend you try that. It's really hard and annoying. You have to move all these joints, okay, and all these little subtle movements. And trust me, it gets annoying. So a solution to this is actually to use a joint solver, and the joint solver will help you rotate these bones by setting a end and a beginning, and it will set up your bone rotations. So let's go here. Oh, they changed it. I actually have to actually click on one. I'm going to use one of these inverse kinematic joint solvers. And now we just have a goal point, and the goal point is the only thing you have to animate. Oops. Oh, oopsies, oopsies, oopsies. Uh oh, I'm locked out. What's going on? Did I do this right? So we got animation, joint solver. Use that one. There you go. Now I can move it. Sweet. And so there you go. There's your walking animation. So it makes it a lot easier. You just have to move this point. You're not dealing with the other stuff. Okay. So anyway, you notice how once you bring up this line, it has to like the slag has to like relieve itself somewhere. In this case, it goes forward because that's common. But you can change the direction of that. Yeah, so I think it's in here somewhere. And you can set the, I guess it's called swivel, and his lag will just bend in a different direction. And I think you can set an object, um, which I believe they call the pole, and that is where it's polarized to, I think. Maybe I'm wrong about that. But yeah, so we select this guy again, and we can just make that the pole direction, and then now we can change it to where we want, which is pretty cool. So it looks like in the image examples, it's working in a compass direction, so it's like north, east, southwest. And you set it by changing this number from like 1 to 4 or 1 to 0. And then he talks about the compass directions. So I believe 1, 2, and 3 are actually reserved for something else because in my observations, before I knew about this value, I had documented these three key values, 0, 4, 5, and 6. And so you can see it goes left, forwards, backwards, and right, like a compass. So that's probably setting the knee joint for the inverse kinematics. Now, what's wrong with this study is that he's rotating the bone, and he doesn't say where he's rotating the bone. So that's curious. So I don't have an example set up to play around with this. So I made a post reply just acknowledging it. I don't know where to take it further from this. I just decided from acknowledging it. Yeah, that's what it looks like. But yeah, he's not. If you're rotating it, that doesn't make any sense. You can't rotate this thing. Like if I try to rotate the knee, I can't because the joint solver, the inverse kinematics, they do the rotation. You don't rotate the bones. Same thing with the thigh. I can't rotate the thigh. Same thing with the ankle. I can't do that. Oh, maybe that I can. But this thing I can't. It's not going to rotate. You can only move it. That's all it's for, is moving. So what I would expect is that he's moving the foot. But I don't think he's moving the foot because he's talking. It sounds like he's rotating things. So that's alarming. So that means that the two systems between 3ds Max and the video game are not compatible. That might be a common theme. Obviously, they made basically it's their own 3D editor, but it's the game itself, right? So they have full control over how those mechanics work. And yeah, and so if we're using something like 3ds Max, then we're kind of boned. We might have more flexibility in Blender, but I haven't looked into it. So yeah, that was the discovery about those two values. I could get more into it, but I doubt anybody cares about it. There was a script that I put out probably last year for research on the FCV, the animation file. I was asked to look at it again. I was pretty annoyed by it because there wasn't anything wrong with the structure, and most of the stuff I do is just the structure stuff. And then the other half is like it's just a lot of slave work. You have to slave yourself over the game, test and poke and prod and theorize and test and poke and prod, and a lot of stuff like that. It takes a long time, and I just don't have that time. So anybody can do that. They can load up the game. They can tweak the animations. They can play with it. So this was just supposed to be a debugging tool. So you can open up the FCV. You can see what values are in there. You can modify the values. Okay. I would have probably made a video that complemented this, showing what the file looked like in hexadecimal, so you could figure out and map out what you're doing. So it's like a debugging tool. Like it's just for helping to solve what's going on inside the file. So I don't think anybody's done that, sadly. The information that was put forth about the IK, the inverse kinematics, apparently was released in 2019, which is a long time ago. And I actually went through my direct messages with this guy, and he actually did tell me this. I just glossed over it. And this was actually more than a year ago. So yeah, that's my bad. But other than that, I haven't really seen anybody in the community doing anything with this stuff, so it kind of sucks. There's one guy, I think his name was OpenChrist. They were not English speaking. It was really hard to communicate with them. It was purely through Google Translator, so it was really hard to get any information back and forth. But as far as I understood, they were able to put animations into the game, which was like, oh, really? So I did do that test myself. I don't have a good test set up. That's not the point. This is just for testing purposes. He's actually meant to do that bending thing. I can talk about that a little bit more as well. But the animation came out flawless. The way it was playing back in 3ds Max, including this bend, which was intentional, it's all there. So that tells me that the animation export works, which is great. So let me explain a little bit more about, I guess, the new discoveries in terms of the values. Basically, actually, it's right here. I have like this random thing selected. You see it says -13 and it says 39 and 30. Yeah, that was really confusing me. Like, why was I seeing these values? So the first value is actually your keyframe value. This value rotates the x-axis, whatever, right? Let's just make it up. Let's just say it rotates it like 13 degrees, right? And then you have these values, which I'm like, what the heck are these values? What's interesting is if you increase this value, the rotation will go further than 13 degrees. It'll go like whatever. What's even more interesting is if you make this value 0 and you make this value really high and the bone still rotates. And I'm like, what? How can this thing rotate? We're not giving it a keyframe value. It has a value of 0. That means it does nothing. So how are these other values changing it? So turns out these are I was trying to figure it out with ChatGTP, like what these could possibly be. I think I called these like hermit splines or something like that, or I can't remember. I didn't read into it, but I'm like, oh, that's what it fucking is. Great. There's a similar system in 3ds Max. I'll show it to you right now, actually. So we'll create a bone. Okay, just like a random ass bone, and we'll just rotate it. So it's like pointing up. We'll just kind of isolate it. Okay, so we got a random bone, and then in here you would go. Oh, I think we have to add a keyframe value actually to it. So let's rotate the stupid thing. Actually, you know what? You don't have to rotate it. Actually, I'm stupid. I think you can just create an empty value. So we can go. Let me think. It's been a while. So rotation. Create a rotation key value. I didn't rotate it. I just created a value for it. And then we want to change these to custom. Right. And so our value is going to be. Well, it's not going to be anything, right? It's going to not do anything. Okay. It has a value because I rotated it up. I think that's probably what one of these things are. But otherwise, the slider, it's not changing, right? So if I click back on here, if we change this to 10, and then we play the value back, or maybe it's the other way around, 100. Okay, that's really kind of jerky, but it's probably because I was on step. Probably too late now. But anyway, you notice that this thing's spinning around. And it's not that we've given it a value, it's because of this thing, whatever this thing is. And then when I look at the literature in here, it calls it outgoing and out and in tangent. So this seems to be the velocity of the spin. So it gets spun, it gets energy, and it will keep spinning. It's interesting. So that's what the value is that's in here, the 39 and the 30. These power values spin the value and give you an easier transition, like a smoother like transition. So another example I will provide is we'll just create a box animation and we'll bring up a curve editor. We'll just move the frame like that. Actually, no, yeah, we'll change it back to step. And I'll do that. And so it's just going to go. And what's nice about this is you can look on this graph. You can see the value actually in a graph view. So you can see the value was like whatever it was. And then it stayed for that for the duration up to like frame 6. And then bam, it jumps up. And you can scrub through this timeline. You can see the change right there. It's abrupt and it's not like appealing. So to kind of give it a more organic feel, you basically like draw a line from there to there. And that's what you call linear. Outside of linear, then you get these splines, which are the ability to actually control the tuning of that value from getting from one position to another position. So that's really interesting. So now you see it like run smoother, and you have full access to change the way that value actually comes across. So if I go like that, you'll see, well, we can go like this. Create an S curve, and you'll see it'll click up and then slow, and then click and go fast again. Or you can create something that goes slow and then speeds up. So slow and then speeds up, right? So these things are really important, I guess, for animators to kind of get a certain feel to the animation, and they'll slave over just getting like a microsecond perfect. So those little things those nuanced things are like programmed in or are set into the FCV files between frames. You can see the 39 and 30, 18 and 860. That's what those are. Those tangents that go in and out that smooth out the animation, so the animation is smooth. Problem: I don't know how to transition the coordinates, or not the coordinates, the value scale to match the value scale of 3ds Max. When I take the values from the game and I put them into this mechanic, they don't work. They're so wildly off. The animation just starts going all kind of buzzed out. So that's unfortunate. There's just too much going on. There's all these different data types. They increase the values normalization, and I don't know how to normalize it correctly to stick it in here properly. So I don't know. I can't get it to work there. So right now, when I export an animation, the values are set for 0, which is 0 velocity. So I believe that should make it a linear keyframe, which isn't necessarily bad, but if you're just copying an existing animation, importing it, and then exporting it, you'll lose that little nuance, that little organic feel to everything, which is unfortunate. So that sucks. I will mention that the difference between, you know, what we're dealing with here is like a keyframe value, right? So we would just export this keyframe value, right? It's very efficient. You save out one value, and that's the rotation or the movement that we did on the x-axis, right? I think Legal Soul's program, he exports every second in the animation. So every click or tick, he updates where this is. And what that will do is it will compensate for whatever tangents that are in the game. I don't know what the name would be called for this, but you're basically doing every second. You're baking it out basically. Um, by doing that, you get a perfect animation export from what you're seeing on the screen to what you're seeing in the game, but you're sacrificing all these extra keyframes to eliminate that. So if we can figure out the tangents between, how 3ds Max is doing it and how the game is doing it, then you gain efficiency. So you only export the one frame, and you just tune the tangents, which you would anyway. You normally would do this anyway. You can set it automatically through, I think these buttons here will change them for you to like presets. Anyway, that's the other discovery that I come across. So I originally thought there was 4 values. There is a strange value which actually adds a third value. I'm not sure what that is yet, but for the most of them, there seems to be only 2 values that complement the keyframe value. The first value, value 1, is always the keyframe value. So for example, that would be like the rotation, right? There's more to it, but just to dumb it down, that's what it would be. Yeah, pretty much is it. Okay. So yes, that's pretty much it. That's all that was figured out on the format, but that's pretty far along. We understand that there's some sort of involvement with the IKs, and the extra values are that. Legal Souls just said that the format was complicated. He never actually got into explaining it, and I think we got to a point where we can explain most of the format now. Yeah, which I think is great. Yeah, that's pretty much it. This thing was basically updated and shared with OpenCrist. So I just uploaded the last version that we had in the DM because I think I made some changes. So I might have released one publicly, and then this was one I released to him. I don't know what the changes were. So if there are changes that were major, I don't remember. But yeah, I will show you one of the little teaser thing that I was able to use this to import stuff, and I'll explain something else about it. Just bring in this render. And let's click through this. All right, so this is a cutscene from the game. I have it recorded here. I believe it is cut 4, so we'll just move up to cut 4. So this is the cabin sequence when you start the game. This is the debug, whatever, and you see the sequence here where Leon's like, "Hey, dude, what are you doing over there? You seen this? Give me all your money." And then he shoots this guy. So what's interesting about this is this actually connects into a different system. So it's actually playing the FCV, but multiples, and I mean multiples. So what we have here is an event sequence, which is actually a sequence of animation clips, right? They call them cuts. So they're doing camera cuts. They're doing 21 camera cuts, and you can see that in the cutscene if you pay attention. So like the first camera follows Leon, he swings the corner, and then clip, it cuts. So we went from cut 1 to cut 2. If I go back, you're at cut 1, right? It's playing this frame animation, 56 out of 100. I think that's tenths of a second, so it goes by pretty quick. Swings the corner, that cut finishes, new camera activates, it's a new cut. So when I looked at the EVD, it's basically just a sequence of folders from, in this example, in this file, R100 SO3, there are 22 folders because it starts at 0, right? 22 folders, and in each folder is a shit ton of FCVs. They're all animations. So we're talking about the camera is an FCV. We're talking about Leon's skeleton as an FCV. We're talking about the handgun that he's holding as an FCV. We're talking about this guy over here as an FCV. We're talking about the lights being an FCV. No, actually, I take that back. The lights is actually just a lit file. Actually, I take that back. But anyway, in each one of these folders is basically all the animation data that you need to play this sequence. And they just run in tandem. So anything that's in that folder, they just run through it. It's really interesting. Now what glues this together is like a graph, and the graph calls the folder and then the assets on the folder, and then they'll get loaded up into the models. So it's really interesting. So I'll just briefly show you that. So this is a printout from just that one event file. This is the layout of the file. Not the layout, but basically that node thing where they explain how the scene works. So in here, each I guess layer, or command is given a cut index. That's like its order in the animation sequence. -2 seems to start the sequence. -1 appears to load assets, and then once you get into 0 and on, it starts playing the sequences. They all seem to have cameras in them to start the cut, and including lights, and including the model packages, which are assembled up in here in the loading sequence. So then it calls these commands. I don't understand what they do yet. You'll notice that there's a hex value. These are like call commands. So each time you get like one of these commands, it does something, right? So looks like 3 loads a model. Looks like 4 appends something to that model. 6 looks like it plays a camera. E looks like it loads lights. B looks like it loads objects in, which are these packages. Looks like here it renders the package, does all this stuff, and then like this is each a cut. Like this is a cut, this is a cut, this is a cut. A cut finishes when it plays through this FCV, and it finishes the frames, and it goes to the next one. Really interesting stuff. The only thing I'm missing to finish my understanding of the event file is just these things in bold. I don't understand this command here. I don't really quite understand that. So I'm probably just gonna move on from it. I have no idea what these numbers mean. Like 7, 6. Like what the fuck does that mean? That makes no sense. But anyway, in the folders, there's just a shit ton of FCVs, and they'll have the same nomenclature. So they just have this index. So this index is it just correlates with the current cut that you're in. So if you're in cut 9, you basically just load every FCV that has 9 at the end and just play it on whatever you have to play it on, be it the camera or the models that are loaded. It's really interesting stuff. So this cutscene here, I imported the assets from the EVD and the camera. So this camera sequence here pans over his shoulder while this guy's poking through the dirt. Then he walks over here. Then it goes to the next cut. Okay, so that's interesting. I thought that was cool. Okay, so here we'll bring up the camera that was in the game. Yeah, camera 1. It's over his shoulder. We'll just click off this somewhere. It's kind of weird. So you can just see this animation play out. So we start from 200. Notice the arm is in the wrong direction. I'll talk about that in a minute. This is actually Leon's model. I had some problems importing multiple models. I wasn't prepared for that, so it just applies animation to one model. So this was kind of a circus show trying to get more models in here. And I'll also talk about this. I don't know if you noticed this clip here. Talk about that. And that's pretty much it. So everything seems to align. I was able to verify the camera. I was able to actually bring up camera information within the GameCube ROM through the debug menu, and so I was able to match this up. So we have, I'll talk about that later as well. Okay, so let's see. I was going to talk about a few things here. So I think I was going to talk about the animation. So I'm having issues with the animation. You notice that he buckles forward at some point, and to me that's a glitch. As far as I can tell, just verifying keyframes in and out, the keyframes are right. What's happening, I think, is an incompatibility with the way that I import the frames. So the way I import the frames is I get an X, a Y, and a Z rotation, and I import them sequentially. So, like for example, this keyframe has an X, Z, and Y like frame. So there's three components that complete a rotation. But on other, this is actually a bad example, but on some other things, you may only have, well, I can just kill these. So you can delete an X or a Y component and just have one component. So that means you only have to save a value for the Z component. So this is like optimized in a sense. So the way that I import it is if I have like a X component, then I import the X component. But it's sequential, so it goes X, Y, Z. I think the way that I'm doing it is actually it's triggering a thing called a gimbal lock. And 3ds Max, I think, is automatically resolving the gimbal lock by flipping the rotation of the bone, and that's why the bone points in a random direction. It's because it's encountered a gimbal lock, importing these keyframes, and I get this issue. So anyway, I don't know enough about animation to fix it. I think I understand the problem, but the issue I think is the way that I'm doing it. So really there needs to be another approach and somebody who actually more understands this thing to solve it. It needs to be fixed in the script. I just don't know how to bring the values in correctly because it's not something that I'm used to. But other than that, I can take this animation and I can export it. Even the way that it is now, even if it's wrong, it will still stay wrong. So if you import them right or wrong, doesn't matter regardless. When it goes in the game, it seems to be correct. So here, I don't know if you can see this clip, but this is just a section of it. He bends over. That was actually what I was experiencing in 3ds Max, and I wanted to see if it was going to carry over, and it did. So that means it's preserving the frames perfectly. So the issue is not actually bringing frames into the game, but rather bringing frames from the game into 3ds Max. I think it's encountering a gimbal lock, a compatibility going from earlier angles to this thing. But I think the early angles are corrected, and then it's exporting correct into the game, and it's fine. So there's something on this end. So that's good. What else was I going to talk about? Oh, the camera. I think I was going to talk about the camera. Yeah, so this is a camera that we loaded up here. You'll notice that typically the way they do this is the bones are indexed, right? So the weapon is indexed. It starts from 1, and then Leon's body is indexed. It starts from 1. The Ganado, the enemy, his bones indexed from 1. So you can apply these animation files like anything. It uses an index number, and if it matches an index number or something else, it just applies the keyframe value to it. It can make it a little bit confusing, right? Um, okay, so anyway, so the camera here, we have these index values that go 0, 1, 2, 3. They don't correlate to the skeleton per se, but they correlate to different components of the camera. So I was able to correlate that because the data is printed here on the screen. So I just have to look for the keyframe value and whatever. So this was actually 0. This is the node 0, node 1 or index 1. This is index 2, and this is index 3. So that's what these are. They're not bones. They actually correlate to the camera components. This is the camera position, the camera target position. That's the roll or tilt of the camera, and this is the field of view. So let's talk about the cameras. The cameras seem to be correct. I just want to talk about that for a little bit. Actually, reset this. And we'll just create a camera. Okay, create camera. So you can't really rotate a target camera. It's a target camera, so it looks at this object. So when you move the object, the camera actually tracks it. And vice versa, if you move the camera, it will continue to track it, and that will actually cause it to rotate because it's tracking. So you don't really rotate the camera, you just move it, right, to get your rotation. So there's not really a rotation, but you can tilt the camera. That's the only thing you can really do, right? So I wasn't actually able to correlate the roll properly because they never use the stupid thing. It's always 0. I know that that value is the roll, but I don't know what the value means. So I don't know if it's like radians or like what the hell it is. So actually the roll is actually not supported. Like it doesn't import the roll at all. When I imported the roll, the camera was doing this, and I was like, well, that ain't fucking right. So I just left it. So just so you're aware, when you import the camera, there's no roll. I skipped it, but trust me, they don't even use it anyway. I mean, you can use it. I mean, it's probably important, but I didn't bother with it. Okay, so we talked about. Oh, I guess the only thing I could talk about is the way you can import stuff, right? So let me just go to this guy. Yeah, let's go this guy. Yes. Okay, great. So again, you can apply these keyframe values to anything. So I had to make some additional right-click menus in here. So you right-click on this, and you'll get some additional add or apply things. So you would, if you wanted to apply a skeletal animation, just find a whatever, and then right-click, and then go to apply. And that's going to apply it to the bones. So it's going to look for bones, and it's going to apply it to the bones, and then somewhere there'll be an animation of this guy, like, and that's the glitching I was talking about. That's the gimbal locking, I'm pretty sure. Also, there's some jitteriness. That's because I have to have you have to have this on linear. I didn't bother to fix it in the script, so you have to have this on linear. I should have mentioned that. So let's undo that, and we'll load another one because that one's like glitchy anyway. Do that one, and the animation should be smoothed out. You could also try with smooth. That's smooth and that's linear. So you can see the animation is a little more smoothed out. I think this is an enemy or something like that. So that's kind of why it looks a little bit off. Okay. And then facial animation is different as well. It's not bones. It's actually a set of vertices that change the shape of the face. And it's in a modifier called a morpher. And you would, oops, I'm going to move that below that one. You would use that to change his facial expression, basically. Yep. Okay. So again, that's different. So you have to select the object that has a valid morpher modifier. Then you right click in here. This is not a, you can, again, you can apply any values to this thing. Like I can apply this and it's gonna like screw his face up like you have like no idea. Like it's messed up. So you have to select obviously one that's for facial animation. So this is the enemy. We'll see if the enemy one works on Leon. I don't know if it will or not. And we'll just apply that there. And we'll see that's what the animation does. The eyes, I guess, are not included with that. They must be tracking them somehow. But this seems to be working. And just remember, this is just some person that worked on the game, spending like 8 hours a day just making sure that this looked natural and everything. This little clip here probably took them all day to do. That's just, I think that's wild. Now everything is live capture. It's done through an actual actor with little dots on their face, and they use machine learning to figure out the facial stuff. Back then, you sculpted it by changing these dials. It's just pretty interesting, right? Fascinating that they did that. If you want to do a camera, and it's a special object type because those different properties are what you're moving. It's not like a physical object. So you don't, yeah, you have to open up a camera. It's not like it's special. It's just they're just values in a file. So you can take any camera you want, and then you just right click and go create camera, and then it goes like that. Okay, there you go. And it should camera should animate. Right. Okay. So just some additional things to the script that I thought worth mentioning. The script again, it was worked on originally to help the community debug and help discover things about the format because I was at a loss at where to go with it. And then it looks like the thing was being shared around. I was talking to this, I think he's Spanish, Open Chris, and he was trying to get it to work, and he got it to work, and I was like, that's cool. And after that, I just didn't hear anything. I didn't know what was going on with it or the community. So anyway, I just thought I would recap what this thing does, just so everyone knows what it is. It's not primarily made to be as a tool to mod the game. It still is just for like basically using it to debug and discover what's going on with the FCV. But as it is, actually, it actually works fairly functional, which is pretty cool. Anyway, that's it. Bye.